Okay, so on our warm-up for chapter 23, you, of course, do a phantoms first. Okay, so let's go through that. Our parameter is the average mu equals, don't forget to put in your little letter mu. So mu equals the average credit hours per term for all of this professor's students. If you didn't use that word all, it's probably okay. Just want to make sure we know it's about a population. The null hypothesis, mu equals 15 hours. For the null, the alternative, mu is greater than, because it referenced, she thinks that the average is more than 15. Okay? I'm going to skip the assumptions for right now and come back to that in a moment. This is a one sample t-test for means. A one sample t-test for means. Now, let me discuss with you what work I did and what work has. I actually showed this formula here. You don't need to. Because we get all of these individual values, I am going to allow you to just write what the t-score is, because you'll get it from your calculator. Pretty much that's the only way here. And then what the p-value is. I mean, technically you could do this without the calculator, but it'll be a lot more work. And it was 0.00079. So you can just write that as the things that you need to include. Yes, ma'am. No. This is not also required. You do not have to write this, but you will need this when you get down to the panic model. Okay? Now, let's go over how I got that information again. Because I was given all of the individual pieces of data, where did I go and put those pieces of data? Into my list, into my stat edit. So I put them all into my list 1. Then I went to go calculate my test. So I went stat over to tests, and I did a t-test. All right, so you need to make sure that data is highlighted, because you're getting all the individual pieces of data from the sample. Now, here's another thing I saw makes mistakes of. This null hypothesis is 15. You got a t-score of like 36 something, you had that as 0. The null hypothesis is 15. Your data came from list 1. This was a greater than, and so now we go and calculate it. Okay, so it gives me the t-score of 3.58 and the p-value of, now see, look at that, 7.896. If you see something bigger than 1, look at the end of the line. It's times 10 to the negative 4th. So that's 0.00079. Okay? Now, look at what else information it gives you on this. You need this for the panic model. You need this standard deviation or the x bar and the s of x. So write that down somewhere. Maybe you need to go write that down there on number 2. But you need that, these 2 items, to be able to do number 2 with. Okay, so there's where you got your things from your calculator. So let's go ahead and look at the conditions. For our conditions, we had randomly selected students was stated. Independent. 24 is less than 10% of all this professor's students, and we knew that because it said in the problem the population, she had 250, so it's less. Yes, sir. Oh, did they not? Then I would have to say assumed. Yeah. Okay. All right. So it is not large enough. 24 is not greater than or equal to 30. So before you start just putting down a histogram, though, or a dot plot, go double check. Does it say somewhere up here that it's approximately normal or anything? Because if it does, then you're good to go, and you don't have to. You can write, it says that it's approximately normal. So it doesn't. Okay. Don't forget that. That might save you some time. Okay, so here's the things I'm going to be checking, and I don't know why I didn't finish filling out the dots on this. And there were, I think, 3 on this one. So I will be checking to see that you labeled credit hours, number of students, so that will be an X that I do. Also the dot plot itself. So the graph itself. Okay? And now let's discuss, I want you to think common sense wise. If you got data and you graphed it and it made a graph that looked like that, okay? What would this sample picture make you think the population looks like? Yeah, I mean, I would feel pretty good about the population, right? If my sample looked all nice like this, I would feel pretty confident about the fact that my population is unimodal, somewhat symmetric, and has no outliers. I was looking at that this morning and I thought, you know what? I should start this thing where you have to say sun, somewhat symmetric, unimodal, and then I could say, you know, we got a mnemonic, you got to do sun, somewhat symmetric, unimodal, no outliers. So I might do that next year. I don't know why I've never thought of that before, but anyway, there you go. Right now it's like us'in need to know what all it needs to be. Okay, so then nearly normal model applies. Nearly normal model applies. Okay, all right, questions then there. Yes, ma'am. Does not matter. In fact, I've seen a multiple choice question on the AP exam type things that discusses how your histogram can look different from my histogram. And that's true. Yours can look slightly different than mine. In fact, some people have gone by different amounts. But it may look slightly different because maybe somebody started at 11 and went 11, 13, 15, or whatever. But overall, they should still have about the same shape. Okay. So since this p-value is low, okay, we're going to reject HO. So since our p-value is less than alpha, make sure you tell me what alpha is. I'm starting to see that creep in a couple of cases. People don't identify somewhere what alpha they used. Okay. So since p-value is less than alpha, I reject that. And, you know, honestly, I've kind of shortened it so that you don't have to do the words right here. You can just say, I am rejecting that mu is 15. So I just wrote the null hypothesis there. I reject that mu equals 15. And then I put context in my next sentence. And my next sentence is about the alternative. I have evidence that, here's context, the average credit hours is more than 15 hours. So that's the alternative. So I have evidence of the alternative. All right, questions on the phantoms. All right, on our panic model, please just say that the parameter and the assumptions are stated above and don't redo those. So this is a one sample t interval for means. All right, now you will need to do this part by hand. You have to show this formula filled in and then show the interval. So those are 2 and x apiece. You don't have to have the formula written out over there because you said it was a one sample t interval for means. But let me have a little discussion with you about some things. Okay? So let's think about our interval formula. I mean, these are on the formula chart in word form, in a generic word form, but you might kind of know these. When we did a proportion interval, it was a p hat, that was our sample proportion, plus or minus, what's next? Z star times the square root of p. Yeah, this is a proportion standard deviation right there. Proportion standard deviation. Okay, but this unit, we have gone to means, so it's no longer p hats for sample proportions. It's what? X bars for sample means. It's a sample mean there, plus or minus, and it's no longer a Z star, but a T star. And our standard deviation is not this square root of p hat 1 minus p over n. It is the sample standard deviation divided by the square root of n. Okay? All right. Now, here's one thing that I noticed over the years that some students mistake this, and so I want to bring it to the forefront so you don't do this. Okay? Some people get this messed up and think that it is this t value that they got right here. Some people think that T star is this number that they got up in their phantoms. That's a no-go. And I want to explain right now why, so that you don't get that confused. So here we go. In fact, I wrote it out here. T star is not the same as the T score that you got in your phantoms. And I'm going to show you why. Up there in our phantoms on this particular problem, it was 3.59. That meant this. I got a sample that averaged right here. And it is 1, 2, 3.5. So it is about 3.59 sample standard deviations above the mean. 3.59 sample standard deviations above the mean, actually. Okay? Here is T star. T star is always coming from how confident you are. So in this case, when we say we are 95% confident, remember what that means? 95% is in the middle. And if 95% is in the middle, here's where my T star is, and here's where my T star is. I have a negative and a positive T star. Do you see how this is a different location than this? They are not the same thing. Okay, that's the difference between the T star and a plain T. All right, so remember that to get a T star, you have to do inverse T of 1 tail, comma, degrees of freedom. So in this case, with 95% being in the middle, I have 0.025 and a tail. So I did inverse T of 0.025, comma, there were 24 in my sample, so 23 degrees of freedom. Okay, so T star is not the same as T. So let's take a look here at what's going on with that. Therefore, my T star I got was that a little past 2. When I did my interval, I got 15.69 to 17.56. So I am 95% confident that the true average of all of this professor's students' semester hours per term is between 15.69 and 17.56 hours. Okay. And one final thing that you will be asked to address. In fact, it'll say something on the number 2. Additionally, comment on if your interval results correspond with the conclusion that you had made in your test above. So let's have that little discussion. What did our test say? Well, in a sense, yeah, our test says reject that mean is 15 and conclude that mean is more than 15. Okay, that's what our test said. What does your interval say? Yeah, the entire interval is above 15, and 15 what? Is not in the interval. So does the results does my interval jive with the conclusion I made in my test? Yes, it does, and you would explain that. Yes, it does correspond because 15 is not in there, or the entire interval is above, or whatever. Okay, so there you go on that. So we're going to go ahead then and